Here's another example of a rational inequality. You'll notice that this one is not equal to 0. So the first thing we want to do is subtract 1 and then write over a common denominator on the left. So you see I've done the work here. We've subtracted 1 from both sides. I had to multiply the numerator and the denominator by that missing factor of x minus 4. And then I simplified the numerator. There's no factoring that needs to be done here, but the next step was to find the zeros of the numerator. So we have 2x plus 13, and this time it can be equal to 0. We want our rational expression greater than or equal to 0. And since the numerator can be 0, we're going to have an equal sign. We see that x can equal negative 13 over 2, but it's still one of our critical numbers. The denominator, when we're finding the zeros of the denominator, we know can never equal 0. So x cannot equal 4. So we have these two critical numbers to put on our number line. Negative 13 over 2, which x can equal. I'm going to use the closed circle to remind me that it can be this number. And x equals 4. X cannot equal 4, which is going to have an open circle. So again, I've got my intervals, an interval from negative infinity to negative 13 over 2, but this time a square bracket because we can be equal to negative 13 over 2. Our second interval, negative 13 over 2 to 4, closed bracket on the first number, and then 4 to infinity. Both of those are open brackets. So again, we want to write our numerator, 2x plus 13, our denominator, x minus 4, and the rational expression all down the left. We need to choose values of x inside each interval. So negative 13 over 2, that's about what? Negative 6.5? It's exactly negative 6.5. So I could choose x equals negative 7. So 2 times negative 7, negative 14 plus 13 is negative 1. Negative. Negative 7 minus 4, negative 11. Also negative. So if we have a negative over a negative, my rational expression will be positive. And remember, we want the r of x to be greater than or equal to 0, which means we want the r of x to be positive. So I know that the first interval is part of my solution. I still need to check every interval. Here, I'm going to check x equals 0. So why don't you determine if the second interval is positive or negative, if the third interval is positive or negative. So we found that the second interval is negative because we had a positive divided by a negative. The third interval was positive. So for this question, we have two intervals in our solution. We have an interval from negative infinity to negative 13 over 2, closed bracket, and a union with the interval 4 to infinity. I've attached some practice worksheets on the class Moodle page, so if you want to go ahead and do some practice here, that would be a very good idea.